Now, proportion can also be used for indirect measurement. Sometimes there might be objects that are too big or too tall for us to measure. What we can use is by using something that's similar, such as a person versus a building, to help us by using proportion to find out the measurement. And we call that an indirect measurement. So in this case, looking at this problem, it says a tree casts a 10-foot shadow. At the same time, a 5.5-foot boy standing nearby casts a 3-foot shadow. How tall is the tree? Now, let's take a look at the picture so you have a visual idea of what this means. We have a tree here, and a boy nearby is standing. Now, why I can say a tree is similar to a person? Because we're both vertical and we're standing at the right angle to the ground. So here, the tree casts a shadow. Let's say the shadow is on the left. This shadow is 10 foot. A boy standing nearby also casts a shadow, and this shadow is 3 foot. And he is 5.5 feet tall. So here, if you can see, both of the tree and the ground forms a 90-degree angle. So it has a right triangle. Same thing, this person standing vertically to the ground. It makes a 90-degree angle, which makes a right triangle. So here, basically, we have two right triangle. They're similar because they're the same shape but different size. They're similar, and we could use the understanding of similar figures, that the measurements of the corresponding sides are equivalent, and we could use proportion to help us figure out how tall is this tree. So right now, let's set up the proportion. So we can have the height compared to the shadow. So let's look at the person first. The person is 5.5 feet tall, and the shadow is 3 feet. And for the tree, we don't know what's the height. What is the height of the tree? So we use x. The length of the shadow is 10 feet. So here we set up the proportion, and by solving this proportion using cross product, we can figure out how tall the tree is. So let's cross multiply. 3 times x is 3x. 5.5 times 10 would be 55. Get the x alone by dividing it by 3. So we have x is equal 55 divided by 3. So it would be 18.3 repeating. So we can say that because of the information we know about the boy nearby, we can use that information to help us set up a proportion to figure out how tall the tree is. And based on calculation, the height of the tree would be about approximately 18 feet tall.